With this video demonstration, we would like to give you a brief introduction about IIT and basic principles of equipment setup and operation by showing you some video clips. Unlike conventional hardness test, IIT measures penetrated depth and applied load during loading and unloading operation, and it is the technologies of getting a continuous curve of load and depth to get versatile properties precisely in non-destructive method. Load depth curve from IIT represents the uniqueness of each material, like the fingerprint of human. We can get diverse mechanical properties, such as hardness, strength, and toughness from this LD curve in a simple, smart, and selective way. Next is about the introduction of measurement for residual stress with IIT. The aforementioned load depth curve is different also based on the residual stress state of the specimen. If we assume that the curve, being created now as loading curve, that representing stress-free state, and if the material is being indented in a condition of tensile stress state, that being pulled to both sides, then maximum indented depth would be increased. This means less load is needed to get the same indentation depth. On the contrary, if the same material but compressive stress from the sides is being indented, its maximum indented depth is reduced with the same load applied, which means higher load is needed to reach to the same indentation depth. The technology of IIT is to evaluate the value and direction of residual stress non-destructively from load difference between stressed state and stress-free state that occurred during these processes. The next is about conversion of residual stress and load difference to tensor. When residual stress is distributed in XY direction on surface, if we put the ratio of these two stresses as P, it could be expressed as following tensor. It gets stress element causing load difference from deviatoric stress with excluding hydrostatic stress, which affecting only to elastic volume change. It can get the value of residual stress and direction because the converted stress value from difference between this stress and load are the same. Next, I would like to show you actual field application of AIS 3000 Compact based on this algorithm. AIS 3000 Compact equipment weighs 3.5 kilograms with 22 centimeters length. It is similar to the size of 1.5-liter cola bottle, and it has different attachments to conduct testing on-site easily with application to tested objects. In addition to the residual stress in basic software of AIS 3000 Compact, programs that calculates out the yield strength, tensile strength, hardness, fracture toughness are available, and it is being utilized in many different fields. Now I would like to show you about the field application for the testing of the residual stress. Test procedure is like this. First, we should choose the most suitable attachment according to the shape of target object. In this video, it is using fillet jig as attachment to tested pipe. At first, we prepare stress-free state specimen. After checking the testing surface, fix the IIT instrument to the tested target with using proper attachment, and move indenter down to implement the testing. This is called reference test, and tests are conducted with dedicated software. You can see the view that graph is being plotted from the software. Next, prepare the specimens of stressed state. This is called target test. The test is conducted in the same way. When it completed both reference test and target test, you can check these two indentation load depth curves on the screen. You can analyze values with specialized software program. The values will be described in MPa unit. The plus refers to the tensile residual stress, and minus means the compressive residual stress. You can test many different shapes of object with proper application of different attachments. The first testing case is for the safety assessment on welding area. The second testing is for verification of post-heat treatment on SG water piping. The third is the application case for the inspection of incoming accessory material of structure. Thanks.